Okay, so today's problem 1845, seat reservation manager. I'll read the problem statement and start solving it. So 10 n 10 n is 10 to the power of 5. So I assume for each call to reserve is granted that there will be at least one unreserved seat. For each call unreserved, granted that a seat will be reserved. At most, wait, to reserve and reserve. So if we're gonna go just through all seats, and then it's gonna be n squared, yes. So it's 10 to the power of 10. So my ideas right now is to store everything, like all seats in all unreserved seats. So initially I'm gonna have like priority queue integer and then unreserved equals new priority queue integer, and then I'm gonna pass the seat 1, seat 2, and I need to go fetch smallest number. So integer compare s1 s2. Okay, that's it. And then in the initialization, I'm gonna go through the I equals 0, I less than n, I plus plus, and then I'm gonna put unreserved offer. It's a good practice to do heapify here, and if I'm gonna just offer, it's gonna be NlogN. But if I'm gonna do heapify for the heap, it's gonna be much faster. The problem is I don't know how. I know how to build the heap from scratch, but I don't know how to build heapify with priority queue. Let's solve this problem first, and then I'll try to explore other possible options. So I'll go unreserved offer I plus 1, and then for the reserve, I'm gonna get the. I know what's happening here. I'm gonna go to the unreserved. Um, Poll and then return, And then to unreserve, I'm gonna unreserved push or offer seat number. Let's check. Unreserved, unserved. Okay. And here I need to return. Okay, I don't need to return anything. Just offer. Oh. Oh. Okay. Okay, so how to make this faster? Um, heapify for priority queue. So the heapify should work like, okay, let's check the timing. So it was like quite easy task, 6 minutes now. So for the how to build the heapify to speed up this process. Offering like creating a heap. So let's assume we have an array, and in array we have and like random order for the elements. Okay, this is not a heap. Start from the first index of non-leaf node whose index is n on over 2 n minus 1. This is the current element I as a okay. Oh my gosh, I guess I forgot how to build a heap. Okay, heapify. So what I do here to heapify, so I need to do sift down for the every element starting from n over 2 I minus 1 to I. Hmm. Okay, so let's check what the heap has. Okay, that's not interesting. What if I try to find heap here? Solution heap. Okay, I don't remember exactly. So let's say we have, um, let's say a heap is basically a data structure where, let's say we have min heap, whether, let's say, children are greater than its parent. So this, let's say 8, this 10, this, let's say 11, or like maybe 21, 10, 11. So this data structure, this tree, it always has children, and they can be situation uh, like this, like here we don't have children, here we have children, etc., etc. We cannot have these gaps, so it should be filled until the last element. There can be like in the end some missing elements, but still. So if I gonna save this data structure in array, something like this. So 0 element gonna be empty, first element gonna be 2, second element gonna be 3, third element gonna be 5, fourth annual gonna be 8, fifth annual, sorry, not annual, for fifth element gonna be 10, and then sixth element gonna be 21. So um, what's the relationship between this one and this one data representation? So for the element, let's say I equals 1, children are what? 2 and 3. So basically it's I multiply by 2 and I multiply by 2 plus 1. Let's check this for the, let's say, for 5. Who can be the children of 5? So if I equals 5, so its children gonna be uh, no, not this one. Let's say 5, this one, 3. 5 is here. So who can be the children of uh, element 5 that's under index 3? So the index 3, I multiply by 2, so here we have 5, and that's basically it. So I base 3 by 2 gonna be 6 index, and 3 by 2 plus 1, 7. So that's it. We have 6, 21, that's children of 5, and 7, we don't have 7, it means that 5 has only one child. Let's do that for the 3 for the index. Let's say I equals 2, so its children gonna be 4 and 5. And let's check. 4 is here, 8, and 5 is here, 10. So the child for the parent and the parent I gonna have child like children 2i and 2i plus 1. So otherwise, if you have a child under index I, what's gonna be its parent? Parent gonna be I over 2. So let's say you have 6 here. 6 over 2, 3, 5 is actually its parent. So let's check it for the for the for the odd. 5 over 3 over 2 gonna be 2. So 10, 3. Yeah, it's it's working. So now let's assume we wanna add the element to the priority queue. Let's say we want to add element here. Let's say we want to add, let's say, element something like 4 or like let's say add 4. Yeah, 4. So how you usually do that? So usually you do that by adding like 4 to the end of the heap, and then you do that shift up operation. So shift up operation, for this operation you check if the parent for the current element is uh, is greater than the current element, you just change it places. 5, this becomes 5, this becomes 4. And you do that until you can. So in this case, you stop right before the root because root is still smaller than the its children element. Okay, let's assume we wanna do this in the next operation. We have this 3, 2, 3, 4, 8, 8, and 10. And then we here have 21 and 5. 21 and 5. So we can always, because it's min heap, we can always get the min in O of 1. So I forgot to mention here the adding element to the heap gonna be log n complexity, where n is total number of elements. In this case, it's like 4 plus 2 plus 1, 7. So it's gonna be log of 7 on average, like. And getting the minimum out of the heap, if it's like min heap, it's O of 1. But what's gonna be if you wanna like extract minimum, or like remove? So we do the following. If you remove 2 here, I do the following. I removed 2, and I basically moved 5 into the root. So I moved whatever we have in the end of the heap, and I move it to the root. So this one becomes 5. And what I should do the next is do this interesting operation that's called sift down. Sift down. So for the 5, I need to check if both children are greater than the parent. So in this case, we see that no. And I wanna select who is gonna be the smallest one, let's say smallest one, or y smallest one. So there are two options. Choose smallest one. If I guess it's indifferent. Yeah, we should choose whatever children is not an parent, and they should be like child should be less than a parent. So in this case, let's say I choose 3. I change the order between 3 and 5. Let's say I do this. Here gonna be 3, here gonna be 5. And now I try to sift down 5 down to its children, but I cannot because both children are greater. Let's assume we're gonna sift down to the so we have here still 5, and we have here still 3. If I gonna sift down to the 4, so you see that the problem here. If I gonna choose the 4, I won't be able to. So I should choose the minimal of the children and sift down. Otherwise, I can introduce the situation when basically in this case, let's say I sieve down 5 on the right branch. In this case, I will just ruin the tree. I cannot like sieve down further because I need to sieve down on both branches. Now I need to sieve down 4 and I need to sieve down 5, continue sifting down 5, and it won't be log n. So in case of I want to sift down, I want to choose a minimal of the two sift down. Sift down. Choose minimal of 2 children. Yeah. And in this case, sift down gonna be log n. Okay. So let me check what's the timing right now. Let me try to implement my heap. So I'll have the integer for the key, and I'm gonna integer heap, and let's say I wanna do this heap equals new integer and +1, and then I wanna so for the reserve I wanna get the minimal element and exclude it from the heap. So let's assume I wanna do sift down for the so let's assume I wanna sift down for the, let's say, int I, and then I want to have int heap. So while I want to find first int child1 equals I by 2, int child2 equals I by 2 plus 1, and I want to check if heap I is greater than heap child1. Let's say if child1 greater than heap, greater or equal heap length, or like length, then I just return. If heap I greater than heap child1 and heap, let's say child1 and child2 greater or equal heap length or child heap1 is less than heap child2, Then I wanna first swap. I wanna say, let's say int. Let's say I wanna write the function private void swap, and then I wanna have int I, int j, and then I have heap, and then let's do that through the temporal variable int temp equals heap I. Heap I equals heap j, and then heap j equals temp. So I wanna swap child. So I wanna swap I and child one, and then in the heap. Else I wanna swap I and child two in the heap, and then I wanna do shift down for the child two heap, and here I wanna shift down for the child one and the heap. Okay, let's do the. So for the reserve here, we need to do shift down. For the unreserve, we wanna do shift up, int I, int heap. So I wanna know the parent for the I equals I over 2, and I wanna check if heap I less than heap parent. If so, I wanna swap I and parent, and I wanna check if parent not equal 0, I wanna do shift up parent and then heap. Something like this. So let's assume and here we want to have also flexible lengths, int length equals, let's say, an initial length, int length equals n plus 1, here not equal 1. So this is gonna be the pointer for the length. Just n. Or let's say length. Okay. Say it's n here. Swap, shift down. So this one gonna be this check. Okay. So for the, let's say we wanna have reserve. For the reserve, we wanna remove the minimal element from the heap. So by how I gonna do that? So I'm gonna get the heap one. So I'm gonna save int t equals, let's say, output equals heap one, and then output one gonna be equal heap length, and then I'm gonna just decrease the length minus minus, and then I wanna do shift down for the first element in the heap. For the unreserved, I wanna do so. For the unreserved, I wanna add element to the heap. So I wanna get the heap length plus one. So let's say length plus plus, and then heap length equals seed number, and I wanna do shift up for the element at length and for the heap. That's it. Um, let's let's initialize that heap here. So what I'll do here, so initial I'll put the just for int I equals 0, or let's say 1, I less than n, I plus plus. And if I gonna just fill it up with consecutive numbers, say we have uh, here, let me get it. If I have, is it working? Say we have 1, 2, 3, 4, 5, 6, 7. Let's say 1, then 2, 3, then 4, 5, 6, 7. Okay, so it's already here. Okay, so if I just gonna fill it up with heap I equals I, and that's it. Let's check. What's swap I parent and heap? Hmm, heap return output. Okay. width length is here and 6, okay. Length gonna be 5. There are gonna be 6 elements. If heap I hmm, okay. Hmm. That's interesting problem. So it's not passing one of these examples. I wonder why. That's all interesting. Hmm. Do we have heap length anywhere else? It's interesting what this example is. Okay. So, oh, so it's very long. Okay, but it's still integer. Okay. Looks like should be working. I can't find any error here. Okay, let me check what I have in my repo. Okay, this one is a while. So for the shift down at I, okay, for the shift down at I wanna do while 2 by I less than I, and don't know. That's a good question. Why it doesn't work? Let me read it again. So we have a heap. Heap equals new integer and plus 1. That's okay. 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 Save down. For the sieve down, I wonder which one gonna be selected here. It seems like they always select. Why I am doing this? Hmm. That's just a more efficient way to write it down. Oh, okay, I got it. I got it. There is a basic error in logic. Else if heap I greater than heap let's say child is if child 2 less or equal length and heap I greater than heap uh, child 2, then we're gonna go like this. Okay, that's better. So I implemented my own heap here and it improved runtime a little bit, but I wonder how I can improve it even further. So there they have this reserve unreserved. So initially they have this initialized array initialized as just new empty. So it's gonna be just zeros. What? Why reserve is not accepting anything? Ah, okay, reserve should return, yeah, should return minimal no, unreserved seed that's about to be reserved. If chi. How the index is related to this? Okay, that's strange. When they talk, maybe that's a solution from editorial. I don't quite understand this one. So we have if character current ch is not zero. Mm. Yeah, it's kind of the same as I was doing with the heap. So if I gonna change it like something like this, heap, say marker, int marker, equals one, let's say, okay, say. So initially I'll put the length equal 0. Let's say equals 1. Or let's say 0. If length equals 0, then I gonna not equal 0. I'm gonna do all this manipulations. Ta-dam! Okay, marker plus heap oven implementation does the trick. So I like that trick with a marker. It's a pretty interesting one. Another level. Yep. So during this video, I showed how to build a heap, and also in this situation, heapify was not even required to solve this problem. Initially, I did heapify with O of n, and now I do that just with a marker, and it's like O of 1 now. Okay, that's pretty nice problem. I'm gonna wrap up. I solved this problem within like first 6 minutes with the priority queue. Then I was a little bit stuck debugging the heap oven implementation, and then I figure out there is a marker solution that gives much better performance compared to the heapify oven um, complexity for the initialization. So that's pass. Hope you enjoyed this video.